Alright guys, this is the video lesson part 2 for Unit 13, Rational Expressions. So, this is the second video to Unit 13, and we are going to discuss and define and explain what an excluded value is. So, let's go ahead first and get this definition down on your paper. And that is that an excluded value or excluded values are any values that make the denominator equal to 0, and those values must be thrown out or excluded from the possible answers for the variable. So what we mean here is that an excluded value is any value that makes the denominator equal to 0. I guess I should have put a period here. And they must be thrown out or excluded from the possible answers for the variable. So, in other words, if you're saying 7 would make the denominator 0, then 7 is an excluded value and it cannot be an answer for x or for m or for q or whatever the variable is. What we're going to show here next is how you actually find the excluded value, and the simplest way to find what the excluded value is to set the denominator equal to 0 and solve. So we're going to get right into it here with example 1. So first of all, with example 1, and thinking about what we did in the last video, there is nothing that can be factored here, right? 5m to the third can't be factored. M minus 6 can't be factored. So there's really nothing that can be simplified here. So, this would just be your final answer. There's nothing that can be done here. That would just be your final answer. Again, remembering that you can't cancel the 3 and the 6 because they're parts of the binomial 5m plus 3 and the binomial m minus 6. So this would kind of be a simplified expression already. There's nothing that can be done to this, but we can state the excluded values. And again, what we mean by excluded values is any number that is going to make this denominator a 0. Well, you're probably saying, well, I can tell that right away that 6 is going to make the denominator 0, and that's correct. But again, the method that I say you might want to think about using here is just to set the denominator, and I say set it equal to 0, but technically we're setting it not equal to 0. I'm saying that m minus 6 cannot equal 0, because if it does, I would have a fraction with 0 in the denominator, meaning it's not a real number, it's an error. You're not allowed to divide by 0. So we're actually solving for the denominator not equaling 0. And again, this would be a quick, easy solve here. So you're saying m cannot equal 6, and that is simply your excluded value, and that's how you state it. You're saying this expression right here is simplified already. That's my answer, in other words. That is my answer, but m is not allowed to equal 6. M cannot equal 6, because if m was 6, you'd have a 0 in the denominator, and you can't have, some number over 0, because that's not possible. You're not allowed to have 0 in the denominator. So that's what an excluded value is. It's an amount, it's a value for your variable that cannot be allowed because it would create a 0 in the denominator. So let's look at number 2 here. And actually in number 2, you notice that there is some factoring to do. Now, careful here. The numerator cannot be factored. The numerator is not a difference of squares. If this said x squared minus 25, that would be different. You would be able to factor that numerator, but x squared minus 5, that cannot be factored. So you're just going to leave it as x squared minus 5. The denominator, though, setting up my t-chart here, trying to find factors of 6 that make negative 5, I'm going to say negative 6 and 1. So my denominator factors into x minus 6. Oh, wait, no, I lied. That's not going to work. Negative 6 and 1 will not make a positive 6. So be careful there. Negative 6 and 1 does not work. What does work? Negative 2 and negative 3. Negative 2 times negative 3 makes positive 6. Negative 2 minus 3 does make negative 5. So now my denominator is x minus 3 times x minus 2. And in this case, this again would be my answer because I can't cancel anything. Since the x squared minus 5 did not cancel, or did not factor, there's nothing it can cancel with. So I'm actually done with my problem, but I do have to state my excluded values. And again, the easiest way to do that is just to set the denominator equal to 0. So you're going to say m minus 3 cannot equal 0, or x minus 3, sorry. And x minus 2 cannot equal 0. So you add 3 to both sides, and you're going to say x cannot equal 3. And over here add 2. So x cannot equal 2. And I just tell you to add that to your answer here. Your excluded values are x cannot equal 2 and x cannot equal 3. Done. Very good. All right, now let's look at number 3. Now 3 is slightly different, so there's going to be a little bit of something different with number 3. So again, first step here is going to be to factor, because again we're going to try to solve this or simplify this and state the excluded values all at the same time. So again, hopefully we're getting better with the factoring. My numerator is going to turn into n minus 6 and n plus 6. The denominator, I'm going to have to figure out what my factors of, I guess that's a negative 30, isn't it? What my factors of negative 30 are to give me positive 1. And I guess that'd be negative 6 and positive 5. Nope. Got my negatives backwards. Negative 5 and positive 6. So negative 5 and positive 6 will make negative 30 and positive 1. So I'm going to have n minus 5 and n minus 6. Now, here's the problem that most people make in this section. You have to state your excluded values after you factor, but before you cancel. And I'm going to put that up here in red somewhere. Let's just put it right here. State excluded values after factoring but before canceling. Alright, so again, state excluded values after factoring but before canceling. And that means that right here my answer is factored, but what you're going to do is you're going to end up canceling this n minus 6. So your answer is going to be n minus 5 over, or I'm sorry, that's my denominator, n plus 6 over n minus 5, and that is going to be your final answer. But what a lot of people are going to do then is they're going to say, my excluded value is n cannot equal 5 because, 5 minus 5 would make 0. But what they forget is that you do have to state anything that could make the denominator 0. And up here in your original problem, a 6 minus 6 would make this 0, and 0 times anything is going to make the whole denominator 0. So you actually have to say that n can also not equal 6. And again, that all comes from up here in this work step before you cancel. So in this problem, your answer is n plus 6 over n minus 5, and your excluded values are n cannot equal 5 and n cannot equal 6. So that's really what excluded values are. There's two more examples, and they both deal with monomials, so let's look at those real quick. Okay, here we go. Example number 4. Again, we just have a monomial over a monomial. And like I said, you're going to say what numbers will make the denominator 0. Well, keep in mind that if this denominator is just 42 times a times b to the third. Well, you're not going to really set that not equal to 0 because it's just a monomial and you can't really solve that. But you just got to look at this and say, hey, what number for a would make the whole thing here equal to 0? Well, and that's just going to be 0, right? You know, if a was 0, you'd have 42 times 0 times whatever b to the third is, but that's gets to be 0. So one of your excluded values here is going to be a cannot equal 0. And your other excluded value then obviously will be b cannot equal 0. Because again, if b was equal to 0 down here in this work, you know, you'd have 42 times whatever a is times 0 cubed. Well, 0 cubed is 0, and 0 times anything makes 0. So a cannot equal 0 and b cannot equal 0 are the excluded values. You still do have to simplify. You know, this problem's not done because you haven't finished working it out. And so just to review here, simplifying here, 14 over 42 are both divisible by 7. So that's going to be 2 over 6. Whoops, looks like it can be divided again, meaning that 14 and 42 are actually both divisible by 14. But anyhow, we'll continue the way we have it here. A to the third over a to the first means 1a can cancel, leaving me with 2 in the numerator. B to the second and b to the third, 2 can cancel, leaving me 1 in the denominator. And again, since I didn't get my numbers simplified down far enough at the beginning, I'm going to have to simplify 2 and 6, and this is going to be 1 over 3 a squared b to the first. And again, this is an example of why we do state the excluded values before we cancel, is because here I just have, you know, I'm going to erase that exponent of 1, and I'm going to erase this 1. I just have a squared over 3b, which a lot of people might then say, well, that means that b cannot equal 0, which is true, but also based on the original problem, a cannot equal 0 either, or it would have made the whole denominator 0 right off the bat before you even did any canceling. So, number 5 here, go ahead and try this one out on your own, simplify it, and state your excluded values, or technically I should say state your excluded values first and then simplify. Okay, so stating my excluded values here, it looks like a is not going to be able to equal 0, because a 0 here would make everything 0 in the denominator. B is not going to be able to equal 0, because a 0 there would make everything 0. And C cannot equal 0, again for the same reason. So, again, with monomials, this is going to be very simple. If it's a monomial in the denominator, none of the variables are allowed to equal 0 because everything in the denominator is being multiplied together. And if any of them were 0, the whole answer would be 0. So let's go ahead and cancel now. 6 over 12 is going to be 1 over 2. 1a in the numerator, 2 in the denominator. So I'm going to be left with 1 in the denominator. The b's cancel completely. C's, looks like I'm left with c to the third in the denominator. So it looks like my answer here is going to be 1 over 2a c to the third, with my excluded values being a cannot equal 0, b cannot equal 0, and c cannot equal 0. Alright, very good. So that's what excluded values are. That was a little bit of a review how to simplify. You should be good to go for all of Unit 12.